2.7. 2.7 objectives. Number 1, verify inverse functions. Number 2, find the inverse of a function. Number 3, use the horizontal line test to determine if a function has an inverse function. Number 4, use the graph of a one-to-one function to graph its inverse function. And then number 5, find the inverse of a function and graph both functions on the same axis. Ready? Okay. So verify inverse functions. Let me give you first of all a definition that I want you to have. Okay? Inverse of a function. I'm going to say let f and not ang and g be two functions such that f of g of x equals x for every x in the domain of g, and g of f of x equals x for every x in the domain of f. So that's a definition of an inverse function. So basically, fog and Goff both equal x. When fog and Goff both equal x, it's not even so much that they equal the same thing, it's the fact that they equal x. When fog and Goff both equal x, you have proven that two functions are inverses of each other. Okay? Remembering also that f of x is function notation, and f negative 1 of x means it's inverse. Sorry. I think I was trying to spell universe or something. I don't know. Okay. So our first objective says to verify inverse functions. So if I give you two functions, for instance, f of x equals 3x plus 2, and g of x equals x minus 2 over 3, I've got to do fog and Goff to verify that they're inverse functions. Okay? So when I do fog, f of g of x, I start writing f, and anytime I get to an x, I write a g of x. So I write 3 times g of x, which is x minus 2 over 3, and then plus 2. 3 times g of x plus 2. Well, when I go to simplify that, that simplifies to 1, which gives me x minus 2 plus 2, so fog equals x. When I do Goff for the same two functions, g of f of x, I start writing g, but anytime I get to an x, I write f of x. 3x plus 2, which is f of x, minus 2 over 3. Well, this goes to 0, and I just get 3x over 3. That simplifies to 1, perfect, which equals x. So this is the way that you verify that two functions are inverses of each other. Okay? Does that make sense? Our second objective for the day is to find the inverse of a function. Okay? So I might give you a function like f of x equals 7x minus 5, and I ask for the inverse. Do you remember how to find the inverse of a function? Yes, you do. Okay? We switch x and y. Now, the part that's confusing for some people, but none of you, I'm sure, is that they're like, there's not a y. Well, remember, we're specifically writing this in function notation, so this is taking the place of the y, right? So when I do go to switch x and y, I get x equals 7y minus 5. Why can't I just put f of x here instead? Do I know for a fact this inverse is a function? I don't. Okay, so I'm just going to use y for now. Okay, but to solve now, I add 5 to both sides because now I'm just trying to solve for y to find out what the inverse is, and from there I can decide if it is a function. So y equals x plus 5 over 7, and now I decide, is that a function? And how do you know it's a function? It's a line, isn't it? Okay, so I can say f negative 1 of x equals x plus 5 over 7. Now what I want you to be careful of is the computer program might not like that as an answer. And what it might want as its answer is 1 over 7x plus 5 over 7. Okay, but you see that they're the same thing, right? Okay, so if you try this one and it doesn't work, try this one before you try to go back and adjust your numbers and stuff like that, okay? So what happens if it's something more like f of x equals x to the third plus 1? Well, I'm going to switch x and y. X equals y to the third plus 1. And now I'm going to solve for y. So I'm going to subtract 1 from both sides. X minus 1 equals y to the third. And I just have to think, how do I undo a y to the third? Cube root it. So if I cube root that, then I have to cube root that whole side, right? So y is going to equal the cube root of x minus 1. Is that a function? So then I can say f negative 1 of x equals the cube root of x minus 1. Let's do another one just for good luck. F of x equals x plus 2 over x minus 3. And I'm going to tell you right now, x is not going to equal 3. Why do I need to tell you that? It would make the denominator equal to 0, so this wouldn't be a function anymore. It wouldn't work, right? Okay, so, but to find the inverse, I still do the same thing, right? I still switch x and y. So x equals y plus 2 over y minus 3. So what do I do here? Yes, multiply both sides by y minus 3. So on this side, that simplifies to 1, right? And on the left-hand side, I have x times y minus 3. And on the right-hand side, I have y plus 2. Do I want to go ahead and distribute here? Okay. Because my whole goal is to get y by itself, except there's two y's, which means I got to get them together so I could factor it out somehow, right? So xy minus 3x equals y plus 2. Why do you want to subtract 2? Okay, but I have this y over here, so don't I need to get it over here with this other y? Okay, so let's subtract xy. No, it's not bad. You're fine. It's okay. Negative 3x minus 2 equals y minus xy. Can I factor out a y on the right-hand side of the equation? Don't both of the terms have a y? So 1 minus x, right? So that equals negative 3x minus 2. Well, how do I get this 1 minus x away from the y? Divide it. So y equals negative 3x minus 2 over 1 minus x. Is it a function? What kind of thing is it? What kind of It is a function. It's a rational function, right? So remember what rational functions look like? Like the two parts with the asymptotes? Okay? Now, again, excuse me, the computer might not like this. And the reason it might not like it is because look how many negative signs are in there. What if I factored a negative 1 out of the numerator and out of the denominator? That would give me negative 1 times 3x plus 2. And if I took a negative 1 out here, that would give me negative 1 plus x, which is x minus 1. And negative 1 over negative 1 would be a 1. So I'd end up with this. Okay? Tell me what can't be true. Sorry, comma. What can't be true? Why? It would make the denominator equal 0. Exactly right. Okay? So this is a function and we can label it f negative 1 of x. Okay? Does that make sense? Alright, so use the graph of a one-to-one function to graph its inverse function. So I'm going to use a piece of graph paper here for that. Okay? And I'm going to give you a one-to-one function means I'm going to tell you negative 8, 3, negative 6, 0, negative 3, 2, 0, 6, and 1, 3. Those are the points on the terms of this function. Okay? 1, 2, 3, 4, 5, 6, 7, 8, negative 8, 3. Ignore that dot. That's a wrong dot. I'm sorry. Negative 6, 1, 2, 3, 4, 5. Negative 6, 0. Negative 3, 2. 0, 6. And then 1, 3. So how would I use this graph to graph the inverse of this function? I could use the graph, because if you'll remember, inverse functions reflect across the line y equals 0. So I could reflect every point on this graph across this line. What else could I do with these points? How do you find the inverse of a function again? Switch x and y. So I could literally say 3, negative 8. 1, 2, 3. 1, 2, 4, 5, 6, 7, 8. 0, negative 6. 1, 2, 3, 4, 5, 6. 2, negative 3. 6, 0. 2, 3, 4, 5, 6. And 3, 1. So the thing about it is if I folded this graph paper right along this line, want those two shapes being lying right on top of each other. Yeah? So that's a way that I can use the inverse of a function, or find the inverse of a function and graph both functions on the same axis. It's also talking about one-to-one functions to graph its inverse function. Okay? How are you feeling about these objectives for today? 2.7? Good. I'm seeing thumbs up, so excellent. I know, that's what I mean. No, you're good.